Look out your window. If you live in a city, almost everything around you, the highways, the towering skyscrapers, the bridges, and the dams, is constructed from the exact same stuff. It's so incredibly common that it's practically invisible to us. To most people, it's just gray, boring, poured rock. But the stability of our entire built environment relies on a bizarre cosmic accident, a hidden property in the materials that engineers discovered by pure chance. If this specific coincidence did not exist, we would lack the physical ability to keep these massive structures standing. Concrete is a master of what engineers call compressive strength. If you build a solid pillar of concrete, you can stack thousands of tons of weight straight down on top of it and it will not crush. But concrete has a fatal physical flaw. It has almost zero tensile strength, meaning it fails the moment it is pulled or stretched. Look at this flat concrete beam spanning a gap. When a heavy weight pushes down in the middle, the bottom of the beam is forced to stretch. Because concrete can't stretch, it just snaps. The beam instantly fails. For thousands of years, this forced engineers to rely on heavy, massive arches. By using this shape, they ensured every stone in a bridge was being pushed together, keeping the material in constant compression and avoiding tension entirely. This physical limitation kept humanity trapped closer to the ground. For millennia, the wide spans and soaring heights of a modern skyline were a structural impossibility. Then, in the mid-1800s, engineers discovered a workaround. They realized that steel has the exact opposite profile to concrete. It possesses incredible tensile strength and can be pulled with massive force without snapping. They began combining the two. By pouring liquid concrete over a dense grid of steel bars, they created a hybrid supermaterial. In this system, the concrete absorbs the crushing downward weight, while the internal steel rebar handles all the stretching and pulling. This hack allowed us to move past the limitations of the arch. It gave us the ability to build the flat overpasses and the skyscrapers that define our world today. But there was a hidden threat waiting inside this new material. Because of the laws of thermodynamics, every material on Earth grows in the heat and shrinks in the cold. Engineers track this movement using a specific metric called the coefficient of thermal expansion. When you embed two different materials together, they must move at the same speed. If you put aluminum inside a glass block and heat them, the aluminum expands twice as fast. The pressure causes the glass to violently shatter. This same threat faces our infrastructure. In summer heat, if the internal steel expanded faster than the rock, it would stretch until it tore the concrete apart from the inside. Without a way to sync this movement, every modern bridge and building would eventually crack and crumble into dust as the seasons changed. Our cities remain standing through the seasons because of a freak miracle of chemistry. Steel is a refined metal alloy forged in a blast furnace. Its coefficient of thermal expansion is 0.000012. Concrete is a mixture of crushed rocks, water, and burnt limestone, and yet its coefficient of thermal expansion is also exactly 0.000012. These materials are completely unrelated, yet by pure chance, they expand and contract under temperature at the exact same rate. Because of this perfect microscopic sync, the two materials move as one. They shrink together in the winter and expand together in the heat, preventing the structures from destroying themselves. Engineers didn't design this relationship. They simply had the luck of finding two materials on Earth that happened to match. The next time you look at a massive skyline or drive under an overpass, consider the gray rock holding you up. This billion-dollar coincidence is the only reason we can safely suspend millions of tons of concrete hundreds of feet in the air. Modern civilization is built on the intersection of brilliant engineering and pure blind luck. If you want to see more of the hidden gears that hold our world together, hit that subscribe button. We'll see you on the next episode.